Sometimes when working with vector data, we want to pull something out of an existing layer, or we want to combine more than one layer, especially if they're geographically next to each other. So let's start with how we extract data. There's different ways to extract. We can use an expression like the population for 2014 is greater than 100,000. And once those areas are selected, we can just save the selected features as a new layer. So that's one way that we can extract data. Starting with queries or something like this, we can extract a new layer. Another way that we can extract a new layer is we can just clip it out like we're taking a cookie cutter and we're just cutting out a piece of this layer. So we start out with this layer here, we use this as a cookie cutter, and what comes out the other side will be this, a brand new layer that's been extracted from the existing information and is a subset of that information. Another thing we can do is kind of use that cookie cutter, but just show what's left after we take the cookie away. So we start out with this layer here, we cut it with this shape here, and now there's a big empty hole in the middle of it, and we would get the part shown in yellow here as the extracted layer. This is a command called erase, and this is a command, the cookie cutter one is a command called clip. Those would be a way of starting with a large layer and taking part of that layer out into a new layer. Another thing we'd sometimes like to do, though, is we'd like to combine two different GIS layers that are right next to each other in space. So in this example here, here's two geologic maps, and what we want to do is combine them into one map. And you can see the advantage here. Then we can just assign the same color to all of the features on both of those maps, and everything looks really good. And hopefully things line up as well. So this works well, but what we do have to consider when we're doing this is the attribute table. And merging is a good command because it allows us to specifically say what we want from one attribute table to be corresponding to in another attribute table, and then that's all going to come out on the other end. So in this example here, you can see in this example here from this map on the left, the formation name is one of the attributes. This lists all the attributes in the attribute table. Here's that formation name. And it's listed here. It has a different name in the Hill City geology, but in the output it's going to be called formation_name2. With units, it's a very different name. It's called units on the Mount Rushmore map and formation_ on the Hill City map. But we can set this all up so that we're actually looking at the attribute table and associating those things we want to and we know are the same between those two different maps that we're combining here. The only thing in the output table is going to be these two different fields, but these are fields that we were once again explicitly able to set based on our knowledge of these maps. A similar command is called appending, and appending is not as flexible as merging. So here once again we're going to put two maps together but we're not able any longer to map one field to another or say, yes, this field in the attribute table, this column in the attribute table goes with this column from this attribute table and make everything work together. So, so fields where the source don't match the target field, they won't have any data once we get the output. So it's fine as long as everything from the attribute tables kind of line up anyways, but if there is some issue with that, it's probably better to use the merge command because you have more control over what your output is going to be. Another way we can do this sort of thing is by generalizing. So basically with generalizing, we're trying to make lines that aren't as detailed, and this is commonly done by removing vertices. We're just basically taking off all the vertices that would more specifically outline some of these little bumps and indentations that we're not seeing with the black line here. And this is another process that we can use. We often use this on large data sets when we're trying to reduce the size and make things happen faster, and also if we're looking at maps that are more zoomed out where we don't really care about all of that detail that we're not able to see anyways. But we have to remember that it can affect both the accuracy and the precision of the data. And the last of these commands is called dissolve. Dissolve removes boundaries based on some attribute in the attribute table. One way to think about this would be maybe counties within a state. If we dissolved on If we dissolved on the state name, we could remove all of the different counties within a state, but still have the outlines of the states remaining. In this example here, this more detailed map includes not only the dominant species in each of these polygons, which is shown here, but it also includes the different ages and the tree sizes, the stand information for these polygons here. So we're able to see that we're able to dissolve or get rid of these lines here, because here everything is the same tree species, but we're no longer differentiating that additional information we had here, which would be the age and the size of the trees within each of these more detailed polygons.